Le problème, merci à Lesia pour leur solidarité. Vous pouvez aller voir à leur stand, hein, ils sont juste à côté de la scène. Donc, je vais vous demander s'il vous plaît d'accueillir pour cette conférence sur OllyDbg, Duncan Ogilvie.
Hello everyone, my name is Duncan Ogilvie and I'm here to talk about x64dbg. So quickly about me, I'm 20 years old, student in computer science, and I have no qualifications whatsoever, so I was quite surprised when I saw that my talk was accepted here, to be honest. So about x64dbg. The official line is an open source x64x32 debugger for Windows. It started in May 2013, and basically it came out of a need for a 64-bit debugger on Windows, and it was greatly inspired by OllyDbg, as you will see soon. I wrote it in C++ because that was the only language I knew at the time, so that's why. Now, there's various alternatives to x64dbg. You see them listed here, but, well, basically, none of those fit my requirements. So instead, I decided to roll my own and, yeah, see how that worked out, sorry. So before I start talking about x64dbg itself, just a quick refresher on x86 assembly, because that's what we'll be looking at for the coming time. And after that, I'll give a quick overview of how Windows debugging works internally. So x86 assembly, it's pretty simple. If you don't think about it too much, you have a few registers. A few of those are special registers that point to the current instruction to the top of the stack, and you have a flags register. Then there's memory, in which there's instructions that your processor will execute. And yeah, there's a stack, which is pointed to by the stack pointer. So quick examples of x86 instructions. The first one, it copies the value of rbx and rex. Should be, if you're familiar, it's probably very tedious, but yeah, that's how it works. Notice the swapped operand order. Yeah, this is for all the instructions. So add rbx rcx will add the value of rcx in the rbx register, and not the other way around. You have push and pop, which push and pop values to the stack and adjust the stack pointer accordingly. There's a call, which will change the instruction pointer to a function and also push the instruction of the address of the next instruction on the stack, so you can return later with the return instruction. And then there's various jump instructions which allow you to implement loops, if statements, and yeah, so you can basically have a program with these. Now, over to Windows debugging essentials. So it starts with this green line here. You create a new process with a debug flag, and then you enter the debug loop, which waits for an event, then dispatches the event magically, and once that's done, you continue the debug loop, and, well, the cycle goes on until the process is terminated, which is indicated by the red arrow. Now, obviously, all the interesting stuff of a debugger happens in how various events are handled. So here's a few things that have to be done in there. So you have some basic housekeeping for processes created under the application you're debugging, threads that are created and closed, and modules that are loaded. Those all give debug events, and you have to just store some information in some data structures so you can use this to debug stuff. Then there's exceptions. So if you do something wrong, the processor will just say something's wrong and throw an exception. Now, the whole purpose of the debugger is to intercept those so you can interact with your program in the crashed state, so you can find bugs or fix bugs. And exceptions are also used to generate breakpoints. So you just insert an instruction somewhere that you know will crash always, and when the instruction pointer gets there, it will say, hey, there's an exception, and you can handle the breakpoint. So you can break the process and inspect the state or something like this. Then there's the trap flag, which you can set, and this will generate an exception on the next instruction executed. And you can repeat this process. It's also called tracing. So you can just step through your program and inspect the state. Yeah, do whatever you want, basically. And there's debug output, which allows the process you're debugging to communicate with the debugger. And it's, yeah, you can use it as a programmer to basically have a debug log. Now, back to x64dbg. My philosophy, at least I think it's my philosophy, is that it should be simple. So everybody should be able to just open the debugger and go debug. Another thing is that it should work on the reality and not assumptions. So various debugger, they make various assumptions about functions or something like this. And x64dbg can do this, but per default, you just get the state. It shows the state. I also try to not reinvent the wheel, because there's great libraries out there, and rewriting them just takes up a lot of time, and it's basically pointless, in most cases anyway. And then I think you should be nice to the user, so the people who are using your debugger should have fun and not struggle with just basic things. They should be just able to debug. Now, the architecture of the debugger, it's very simple. You have, in the middle, you have a bridge, and this bridge basically relays messages from the debugger, which is the core of the debugger. It handles all these debug events, and it will relay them to the graphical user interface, where they can be displayed and you can interact with them. And then when you want to actually, for example, step, the graphical user interface will tell the bridge, okay, I want to step now, and the bridge will tell the debugger. And this way, in theory, it's possible to replace either of the debugger or the graphical user interface. So in theory, it's possible to create a fully headless version of x64dbg. But in practice, of course, it works quite differently, because development is not always smooth, and this interface is pretty tedious to program in, so you work around it, and well, this would give you problems if you try to replace it. But it still creates a nice separation between the debugging core and the user interaction. So you could also choose, for example, to just work on user interaction and just not ignore the debugging core. So this is great for productivity. Now, there's a few libraries that x64dbg uses. The first is Qt, which is the graphical user interface. It's a great library, and since x64dbg is GPL, it's compatible. It's great for productivity, so that's why I decided to use Qt. Then there's Titan Engine, which is, this handles the debugging internals, like these debug events. They're abstracted by Titan Engine to create better abstractions, and eventually also allow this module to be replaced. Then there's dbg help, which is the famous, I guess, not really, it's a terrible library from Microsoft that allows you to load Microsoft's proprietary debug symbols, which is quite useful if you want to load symbols. Well, there's Capstone for disassembling, and probably some of you heard of it. Well, there's Jansen and LZ4 for database stuff, and setparse and Keystone for assembling new instructions. Then there's also Yara. It's integrated, pretty much. So that's also a library I use. Now, I just want to give a quick demo and show some of the basics of x64dbg, so you have an idea what I talk about. Oh, well, that's just great. Right, so this is visible, sort of? Yeah, so this will do. Right, so I just loaded the debugger in the debugger, which is always interesting. So on the left here you have the disassembly view. This just shows you the instructions that are, yeah, currently the black instruction is like the one that will be executed next. So the RIP points there. Then on the right here there's the registers view, which just shows you all the registers and all the basic registers, and also flags and various x87 floating point registers. In the bottom here, you have a small window that shows you information about the currently selected instruction. So, for instance, it shows that this keyword that's referenced inside this instruction is not a valid pointer, and the value of RBX is also shown. And it also shows the current location in the program, which is quite useful at times. Now here's the dump window. It's pretty basic. You just have your basic hex dump with some text. There's various floating point options, integer options, pretty basic. Just what you would expect. Here's the stack. Sorry about the resolution, by the way, but yeah, it's like this. So it's just the basic stack. This black pointer is the RSP. And here's a small widget for arguments that helps you basically with interpreting what's happening. So I'll just do a few single steps. I'm currently single stepping through NTDLL. Oh, kernel 32 actually. You have breakpoints, so you can break here. Just the basic things you'd expect from a debugger. Now there's also symbols, call stack, a memory map, all kinds of things. So yeah, this is basically what you're looking at. And you might wonder, how will this help you with analyzing stuff? Well, that's a whole different story, but this is the debugger I'm talking about, which I just wanted to show you real quick. Right, so developing a debugger is not easy. It's not always fun, unfortunately. And these are just a few challenges I came across, just anecdotes basically about the development, which this talk is about. So one interesting thing is bug reports. They're very nice, but if you cannot reproduce a blocking crash on your computer, and the person reporting the bug gets more and more frustrated about that you cannot do anything about it. This is very interesting experience. Now there were a lot of bugs with threading, which is pretty hard. There's like 5 threads running to make sure your interface doesn't lag behind. And some of these race conditions are very challenging to debug because I don't know any good tools to do it. So you just fiddle around until you think, oh, wait. And then you find a nice to-do item, fixed threading in your source code where you were supposed to fix it. Now, another interesting thing for building continuous integration, I basically rented the server at this company called Cloud at Cost. It's a very interesting company, and my server kept shutting down while building. Makes no sense. So I thought, well, I'll go on Twitter to ask, and everybody was like, yeah, you should read the terms of service. Well, I already did, but they changed them, and according to them, abusive activity is 30 minutes of CPU time, which is very weird because that's just a normal build process. And I checked, and indeed, according to them, I'm responsible for frequently reviewing this agreement posted on Cloud at Cost's website to obtain timely notice of any such changes, which is pretty hilarious. And frankly, illegal in Europe, as far as I'm aware, but I'm no lawyer, so I don't know. Now, another very interesting challenge is the fact that all the libraries that I use are open source, which means if there's a problem, I can just check the source code, except for the Microsoft's dbg help library, which is very interesting. So at one point, I got a bug report that said, yeah, if I try to start this process, it will take at least 30 seconds until it's loaded. So eventually, I pinned it down to a function in dbg help, and it turned out that it pointed to a symbol file on a network share. So it tried, on my computer, it tried to find this share, which obviously didn't exist. And this is undocumented, so that's great. I had to dig through to the disassembly of dbg help to figure out what to do about it. Turned out there was an option, but documentation said it did something else. So it's a very interesting challenge. Right, so a few numbers. What are we talking about here? It's been downloaded about 158,000 times on SourceForge. So that's pretty nice, I guess. It says that a lot of people are using it, although I don't know who those people are. So contact me if you ever use it, and yeah, tell me what your experience was. So there's a few other interesting things. It's currently 113,000. I cannot read numbers, but it's a lot of lines of code. It was a lot of work. And the amazing amount of $1,490 was raised. So thanks to all the donators. It's really great to have you. Right, so x64dbg is built for reversing. So what do I mean by that? Well, there's various small things built in to ease you as the user. There's an imports rebuilder built in. It's basically a fork of Scylla, which is a great imports rebuilder for Windows. So if you ever need to dump a process or rebuild some imports, it's right there, it's built in. Yeah, there's a simple notepad built-in, which might be useful if you are very chaotic like me and you're too lazy to manage your notes. It's just right there. It will be stored in a database. Now, frequently there's just a few small anti-debug tricks that are done by the process to check, and there's simple countermeasures built in. So these are not foolproof, but they do the basics, so most things get hidden pretty well. You can copy data very easily in various formats, so you can copy some data to a C-style array or to some unsigned long array or something like this. and you can very easily patch executables. It's you change the memory, you hit patch, save to file, and it's done. So that's pretty useful if you're trying to patch something. Unlike IDA, where it used to be pretty hard, I think, but I cannot afford an IDA license, so I wouldn't know. There's also a feature which we took from Redare. I hope I pronounced it correctly. And that's the mnemonic brief, which gives you a very brief description of what the instruction does. And this can be very useful, especially if you have to check which type of conditional jump, which flags it will use. And there's also a very hidden but useful feature that's help in symbolic name, which will just Google any label or basically any label or reference address that has a name. It will Google it for you, and well, hopefully it finds something useful. Now, obviously there's breakpoints built in, and there's some sort of tracing built in. It's not like fully functional yet because it's pretty difficult to get working. But there's conditional breakpoints, so you can just specify your condition. There's also logging built in and logging conditions, so you can break on certain conditions, break and log on other conditions. And you can also execute commands, which might not seem very useful, but because it's only one at the moment. But with one command, you can just call whatever C++ you want, so you can do anything you want with breakpoints, basically. And there's pretty simple conditional tracing, so just step until EAX equals to 0, and then it will stop. This can be useful, for example, if you just need to find a spot where you know something's going to happen, but you cannot really know where it is exactly. I will show something in the demo. Right, so there's plugins, like OllyDbg, those that had beloved plugins. Most of those plugins fixed bugs. In x64dbg, these plugins should, in theory, do stuff. So the philosophy is keep it very simple, again. It works on a very basic event subscription model. So you say, I want events. If the debugger pauses, give me an event. And the debugger will give you events when the debugger pauses. So you can, for example, log this somewhere on the disk, or just resume debugging to screw with the user. Now, there's also x64dbg Pi, which is sort of a pun, but not really. It's a plugin, so I have basically nothing to do with it, except that I have commit rights to the repository, but I'm not really involved. I don't use Python, so yeah. It's written by Tomer Zaid. I hope it pronounced correctly, I don't know. And yeah, it's fully implemented as a plugin. So there's a few, I added a few API functions that he needed, but apart from that, it's yeah, it's a plugin. There's no trickery involved, and you can pretty easily write your own Ruby plugin or PHP plugin if you're crazy, or something like this. Now there's also Yara built in. I mentioned it briefly, and that's the pattern matching Swiss knife for malware reversers, according to the official website. And it's integrated, so you can load a signature, check if there's any matches in various regions, and also you can check the file directly if you want, so you're not restricted to just memory or just the file. You can also, in a dynamic state, just use Yara on it, and maybe after you unpacked something, maybe you find something else interesting. And this is integrated as a simple command, and for that command I created a simple user interface, so it's very minimal. It doesn't require much effort at all. Now there's also decompiler built in, which I didn't write, again. I just took the source code, I did some modifications, and just plunged it in there, basically. That's how I did it. And I made the various changes to make it look a little better, but and you can move around from the decompiler to the disassembly view, so you can inspect the decompiled source directly. And it's very loosely integrated, so there's only like one, I believe, no, two functions that are called, and you can also very easily replace this with, for example, nothing. If you don't like a decompiler, you can just be like, I don't want it. And now I'm gonna give a small demo, or at least try, that involves Python with Z3, which is a constraint satisfaction library, I believe. And it also involves Yara and Snowman. Right. So on the abstract, it said there would be a demo on a real-life scenario. Well, that didn't quite work out for various reasons. But I wrote a small crack me instead, which should be pretty interesting as well. So let's first, let's see. Right, so this is simple crack me. You just open it, it says enter key. Very basic, of course, it's just to show the features. So you enter a random number or something and it will crash. Presumably because it was programmed very badly and it will crash if you enter an invalid code. Right, so this is the entry point of the executable, which is visible here. And I can just search for strings, which is always a very easy approach if you are just starting. And luckily, I mean, it doesn't really matter, but there's some references. Right. This is pretty small. Maybe this is better. So here we can see that this crack me, it calls printf to print this enter key message, and then it calls scanf to get a key of the type long hex. So we need to enter a long hex number, and it's in a loop, so it will just ask keys until you enter the valid hex number, basically. Right, so let's run this. I can use run until selection, for example. It's one of these features that's pretty useful if you just want to quickly go somewhere, and it will ask for a key. So just 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, something like this. This is a very basic key. Now when we break, pretty straightforward. And the key is somewhere inside. Yeah, where is it? Here. As you can see, the key is referenced by this instruction inside this memory address, and it will move this key in RCX, which on x86 is the first argument of a function. So it will put this key in a function, presumably to check it or something, right? So I go inside this function, and let's just quickly analyze it. Analyze single function, so you get like nice boundaries. And let's decompile it. So decompile the function. So what this does, I didn't invent this myself, but it's a very interesting crack me. It basically multiplies RCX, which is the key, by itself 7 times. So you effectively get RCX to the power of 7, except that it will be cut on 64 bits. So you cannot take the square root of this number because you wouldn't end up with a valid value. So for this, we have constraint solvers, which should be available somewhere around here. Right, so I wrote the script. Right, so it does exactly what this decompiled function does. It creates a bit vector, which is basically a fixed integer of 64 bits. and it tries to find a valid key. Right, so I can run this script like outside of a debugger, but I mean, that's not even remotely interesting. So I just will run it from inside the debugger. So it should output a key in a few seconds. Right, so the constraint solver magic found a key, which is in decimal, but that's not a problem because there's a very handy calculator built in where you can just input basically anything and it will give you the equivalent in different bases and stuff like this. So the valid key is this. At least that's what I assume. I mean, I didn't make this crack me or anything, just an assumption. So there was something else interesting going on, which was the fact that it crashed when it was invalid. So we'll take a look at that real quick. So let's just run it and see what happens. Right, so it crashed with an exception on 00000, and all the registers are zeros. So I cannot look at the stack or something to figure out what's going on, or where it came from, or where it crashed. I mean, so I will have to try again. Right, so the entry breakpoint again, and the string reference to this key again. So let's just put it here, run here, and just enter an invalid key just for fun. And so now I'm here, and eventually it will crash, but I don't know where, and I don't want to figure out by manually tracing in. So that's why there's conditional tracing. You just trace until condition, and which was like rex equals 0, and wait, did I type 3x? 1, 2, no, okay. rbx equals 0, and say, I don't know, rcx equals 0. So I just trace. I have no idea what's going on now. It's still a demo. Oh, right, so we're here, and this looks like it's not a module because it doesn't say that it's a module here. Well, you cannot see that real well. Well, it's not inside a module. So let's just check the return address. Right in the stack, it says return to correct me something, so that's probably interesting. Follow it, like again, basic things. You don't have to manually type addresses. At least it's horrible to type 16 number addresses by hand without errors. So basically it went somewhere here inside rbx, and it looks like it did something with a buffer, but it's, yeah, so this is basically why you would want to trace with a condition, because you can find stuff like this. But we already have a valid key, so it's rather pointless. I believe it's on my clipboard, yeah. So we can just restart, oops, run. Right, so break here. Enter the valid key instead. Enter. Right, so now it will, this function is checking the value if it's correct. And notice how it just went back to the previous location there with minus, so you don't have to remember everything. So just this should pass, right? So we step over here. And this function, well, it does something. I have no idea what, but we're going to try to use Yara on it, because Yara is good for detecting things. And let's see if Yara can find something. So I just go to the symbols, which is also a modules window, and I just do Yara on file. And I have some crypto signatures here, some packers, some compiler signatures. So let's just try to find some crypto. And well, it found some MD5 constant. So apparently this function is MD5. So we know that. We just use Yara, and it's pretty easy. Right, so this does something with an MD5, something with buffers. It's pretty pretty vague. If you want to inspect it in depth, I can post this correct me somewhere. And it prints congratulations because we did it. We defeated the magical algorithm to correct me. So that's a small demo. It's obviously quite canned because yeah, I wrote the correct me myself, so I know everything. But tell me if you recognize correct me. I will love to hear the story. So back to my slides. Right, so that was the demo. I hope it showed a little bit what like Python can do. I mean, there's also integration with that you can actually debug stuff, but I couldn't find a good example, so I just showed this. Everything is open source. You can always ask me if you need some information. Right, so there's also other plugins. How am I on time, by the way? I don't know. There's also a few other plugins. So if you need more advanced debugger hiding, there's Scylla Hide, which is written by some very skilled people. They know how to write hooks, and I don't really, so it's a plugin. And it's for, yeah, prevent anti-debugging. I mean, prevent anti-debugging, so it's anti-debugging. And recently there was a tool, I mean, yeah, a tool was released called alt-caser, which was aimed at testing if your malware environment was basically safe or undetected. So, yeah, you have to take it from me now because I don't have a lot of time, but it works, so everything is green, and without Scylla Hide, it's red. So they did a great job writing that. So about the UI, you can customize everything. Most people dislike the default color scheme. I like it, but you can change everything pretty much. Yeah, you can also style your windows, which is built into Qt, but I mean, I don't use it, but you can, so it's great. And the interface is fully translatable. So the translation has been up for about, I think, a month now. And Russian, Chinese, and German, and Italian are pretty close to being translated. So that's great from the community. They're great people. Yeah, there's also an entropy graph built in. And there's full Unicode support, which is very vague, but basically you can have full Unicode support, but per default it's not, because it's very slow to draw. And optimizing the UI is very hard, especially because Qt has internal caches that are really hard to figure out without going in their source code. So you can, but it will be pretty slow if you try to do some high performance stuff. So per default it's disabled, but you have, like, you can go to all code pages, you can view any language if you want. Now, various people of the community, the x64dbg community that is, are watching. You guys are amazing, thanks. Just wanted to say that. And I'm out of time. Yeah, I have like more content. I can talk more. But I don't know. All right. So I have some more content, but you can ask me, Twitter me. You can find me on the internet. It's not so hard. Just go to, let's see, here, this website. It will show you ways to contribute, how you can come in contact, and that's about it. Any questions? No questions? All right. Thanks a lot.
Thank you very much. I have to admit that your work is impressive, and you said at the start of your talk that you were kind of wondering why your talk has been chosen. And I would like you to remember that the New Hack, it's a place where we like people who try to make hard things. And when we saw that you were a student, for us it was not a problem, it was something positive. Because here it's a place where everyone, experts and students and beginners are welcome. Thank you very much. And you are not a beginner. Okay, thank you people. We will make an announcement. All the people playing for the CTF challenge have to join the war room now. If they didn't do so actually. And Guillaume is willing to say us something.
Je voulais dire un truc. Yes. Alors, Guillaume, ils connaissent pas.
Ah putain, ouais, vas-y, c'est pas grave, vas-y.
Alors moi j'avais juste un truc à dire, rapide. Je pense que dans les autres salles ils vont m'entendre. Bon, je remercie déjà tout le staff de la nuit du hack, les conférenciers. Mais avant, j'en profite parce qu'après je remonte plus sur scène parce que on m'interdit de monter sur scène. Juste pour vous dire que le bug bounty, il faut y aller. Il y a encore beaucoup de sous à gagner. Il y a des super scopes. On s'est cassé la tête pour vous trouver des trucs vraiment bien. Donc vous vous inscrivez et vous pouvez peut-être même amortir votre place dans la nuit du hack, même le voyage, même les binous. C'est super important. Alors montrez votre skill. Et puis il faut y aller. De toute façon, c'est pas en faisant rien que vous allez trouver quelque chose. Donc bon. Allez-y, on vous attend. En tout cas, ils sont chauds, ils sont tous là-bas, là, ils s'endorment. Il y en a qui traînent de temps en temps, des vunes, des trucs sympas. Il y a OVH qui est chaud, là. Il y a Orange aussi. Mais bon, ils dorment. Non, ah non, ils sont là-bas aussi. Ils sont pas très bruyants. Et il y a Compte. Bon, bah, du coup, je compte sur vous. Amusez-vous bien ce soir. C'est pas fini. Merci, Claude.
Je t'en prie, ma poule. Mais peut-être, tu sais que les gens n'ont peut-être pas le niveau. Ou peut-être, ils savent peut-être pas montrer ce qu'ils ont dans le ventre, je ne sais pas. On va essayer de voir si ça bouge en tout cas. Merci de continuer les challenges, franchement ça fait vivre l'événement. Et je pense que les sponsors qui organisent les Bounty Challenge, clairement il y en a pour certains qui sont là déjà depuis 2 ou 3 ans et je pense qu'ils ont quand même appris certaines choses. Donc c'est aussi peut-être que la difficulté est plus élevée. Et c'est pas une mauvaise chose. Mais il ne faut pas oublier que là, quand vous attaquez leur système, en fait, vous attaquez des systèmes réels, des systèmes qu'ils mettent en production, qu'ils ont déjà en production. C'est-à-dire que concrètement, vous pourriez le faire sur le site en production. Voilà, donc il faut juste rappeler ça. Et c'est intéressant que des entreprises rémunèrent des gens qui les aident à trouver des failles. Moi, je peux vous dire qu'à l'époque où j'ai commencé, ça n'existait pas. Et c'était plutôt l'inverse. On vous tapait dessus, même quand vous vouliez aider. Donc c'était un petit peu difficile et c'est excellent que les mentalités aient changé sur ce plan-là et on va continuer les efforts pour faire partager cet esprit. Voilà, donc c'est l'heure de la pause. 45 minutes de pause, vous pouvez aller manger tranquillement, vous allez vers Disney Village si vous voulez trouver quelque chose à manger. Et puis on se retrouve ici pour les 2 dernières conférences. La prochaine sera animée par Virtu, qui va nous parler, non je garde le suspense là-dessus, vous avez le planning de toute façon. Mais qui va nous parler en gros de hacking domotique et je pense que ça va être très intéressant.